Hello students, in the last lectures we have discussed about the stoichiometry's introduction, and along with that atomic mass, molecular mass, as well as the molar mass, right? Okay, and now we are going to see a new term, that is the equivalent weight. That is equivalent weight. Okay, so what is this equivalent weight, right? Generally, what is the atomic mass? Atomic mass is nothing but one atom's mass. Okay, what is the molecular mass? That is nothing but the mass of the one molecule, mass of one molecule. And coming to the molar mass is nothing but it is the Avogadro number molecules mass. It is the molar mass. But now come to the equivalent weight. Okay, then equivalent, what is this? Means Just you have an idea that what is the equivalent weight is. That it is a term, equivalent weight is a misnomer, as it is neither mass nor weight, but it is merely a number. That means generally for the molar mass, it is a mass of 1 mole of atoms or mass of 1 mole of molecules. But here this equivalent is neither mass nor weight. Then what it is? It is even not a mass. Idi mass kaadu, and even it is not a weight also for a particular atom or particular molecule. But what it is? It is simply a number. But it is useful. In the calculations of the normality, as well as in the electrochemistry. In many areas, this equivalent is very, very useful. Okay, right? Generally, it is not neither a mass of any atom or any molecule. Again, it is not a weight also. Okay, right? Are you clear about this? Now come to the definition. of the equivalent weight. And now you can't understand this definition. This again I will explain after that examples. Okay, after the calculation of the examples. Okay, so now first we can see that generally the equivalent weight is different. Generally the equivalent weight is different for different substances. Okay, so it is not same like a molar mass. Okay, it is a little bit different, right? Generally the equivalent weight is different for the atoms, and you can also calculate the equivalent weight for different molecules and acids and bases. So for these are all the things, the calculation of the equivalent weight is little bit different. Okay, so in that first we can go step by step. That first we can go to the atoms, next some molecules or some acids, and next bases. Okay, like that. Okay, so first we can see that the calculation of the equivalent weight of an element means that is an atom. Okay, of an element. Okay, so these examples I'll explain in a different notes, right? So how can we calculate the equivalent weight of an element? Is that very simple. The equivalent weight is equal to, you know, that atomic weight divided by the valency. Okay, so what is the valency? You know that the valency is equal to the group number, right? Generally the first year group of elements, the valency is 1, and for the second year group of elements the valency is 2, and for the third year group of elements it is 3, for fourth year it is 4, but it is up to 4, it is a group number. But above the 4, that means from 5th group to 7th group, the valency is 8 minus group number. Okay, so that means for the 5th year group, 8 minus 5, that is 3, and for the 6th year group it is 8 minus 6, that is 2. Okay, that is the this is the difference in the valency calculation. Okay, and now you see that element for the hydrogen element. What is the equivalent weight of the hydrogen? Let us see very Good example. That is the atomic weight. What is the atomic weight of the hydrogen? That is 1 divided by what is the valency? Generally the hydrogen belongs to the first A group of it. So that the valency is 1. So the equivalent weight is 1. Next, the equivalent weight of the oxygen. What is the oxygen atomic weight? That is 16. And what is the valency? Generally the oxygen is belongs to the 60A group, so that it is a 8 minus 6, so that it is 2. 16 by 2, that is the 8. And next come to the chlorine. Equivalent weight of the chlorine, first of all atomic weight, that is 35.5 divided by valency. Valency, it is the chlorine is belongs to the 7th group, so that it is 8 minus 7, it is 1. Okay, so like this you have to calculate the equivalent weight of the elements, right? And come to the D block elements, you see one of the example. For the copper it is generally 2, and for the zinc it is 2, and silver it is 1. Silver it is 1. Okay, right. And next we can go to the equivalent weight, the calculation of the equivalent weight of ions. You know that generally cations, anions will be there, right? Okay, so now we can calculate the weight, equivalent weight of the ions. Okay, so generally ions contain some charge, right? So for that the equivalent weight is equal to ion weight divided by the charge present on ion. Ion weight divided by charge present on ions. Okay, so let us see some example, right? So if sodium plus ion is there, okay, so for that, for the sodium plus ions, the equivalent weight is equal to, so what is the atomic, what is the ion weight? What is the, here it is the ion weight, right? What is the ion? Here is the sodium plus. So what is the weight of the sodium plus? You know that it is 23. Sodium is 23, right? Okay, 11, atomic number is 11, and the atomic mass, generally the atomic mass is nothing but the ionic mass here. Okay, so this ion mass is 23 divided by the charge. How much charge it is? Only one charge is there, one positive charge, so that it is 1, that is 23. Similarly, you take the OH minus ions. Cation is over. Now we can go to the anion, EOH minus. So what is the ion mass? One oxygen and one hydrogen. So 16 plus 1, 17. 17 divided by how much charge? Minus 1. So you should not take the positive or a negative. You have to take only the number, how much charge. Okay, so that is 17 by 1, it is equal to 17. Similarly, you go with the CO3 2 minus. CO3 2 minus, the equivalent weight of the CO3 2 minus is equal to, the carbon is 12 and oxygen is 16. 16 into 3 is a how much? 32, 48. 48 plus 12, it is 60. 60 by what is the charge? The charge is 2. So that 60 by 2 is equal to 30. Okay, so similarly you have to calculate the all the equivalent weight of the all the ions, right? Okay, this is the way to calculate the equivalent weights of the ions, right? Okay, next come to the equivalent weight of acids. Equivalent weight of acids. Okay, so what is the equivalent weight of the acid? Is equal, very simple. Generally the acids are molecules. The acid equivalent weight of the acid is equal molecular weight divided by its basicity. Molecular weight divided by its basicity. Okay, so what is the basicity? Here it is important. What is the basicity? What is the basicity? Is that it is very simple. That is, the basicity means the number of replaceable H plus ions in a reaction. Replaceable H plus ions in a reaction. Of course, no one is going to be ask you the reactions, but generally you know that very simple. In the HCl, you know that how many hydrogens can be replaceable? Only one H plus can be replaceable, right? One H plus can, right? And come to the H2SO4. Come to the H2SO4, and how many H plus ions can be replaceable? 2 hydrogens, right? 2 H plus ions are replaceable. Come to the H3PO4. How many H plus ions can be replaceable? That is 3 H plus ions can be replaceable, right? Okay, and for this HCl, what is the equivalent weight of the HCl? Is equal to, very simple, that is the molecular weight. HCl is 35.5 divided by, what is the H plus ion replaceable? Only 1, right? So that is 1. So that is 35.5. And next come to the H2SO4, that is equivalent weight of the H2SO4 is equal to H2SO4, generally it is 98 divided by how many hydrogens replaceable? 2 hydrogens, right? Okay, it is by 2, so that it is 49, right? Okay, and next is that equivalent weight of the H3PO4, okay, and for the H3PO4 also the equivalent weight is equal, sorry, the H3PO4 molecule weight is 98 divided by how many hydrogens replaceable? 3 hydrogens, so that it is 3. So 98 by 3 is equal 32.66. Okay, so these are the equivalent weights. These are the equivalent weights for the HCl, H2SO4 and H3PO4. Okay, right. This is the only thing you have to remember. Suppose in your notes some reactions are there like this. Okay, H2SO4 on reaction with the sodium hydroxide and it gives like this. So in this total 1H plus is replacing. So now you no need to worry about all these reactions. Okay, you see this table here. In the first case 1 hydrogen replacing, second 1 hydrogen, and third one here 2 hydrogens, and here 3 hydrogen. If you understand, you read this. If you are not able to understand, you leave this one. Okay, next we can go directly to the equivalent weight of the bases. Equivalent weight of the bases, for this very simple, it is exactly opposite to the acid. That is, the equivalent weight of the base is equal the molecular weight by acidity. Molecular weight by acidity. Generally before the acids, it is molecular weight by basicity. Okay, so basicity is nothing but the number of replaceable H plus ions. Similarly, here is also the acidity is nothing but the number of replaceable OH minus ions. Number of replaceable OH minus ions. Okay, so let us go with the one example here. You know that sodium hydroxide is the base, and similarly the calcium hydroxide is also a base, right? Okay, so here how many OH minus ions are there? You can replace is that 1 OH minus ions you can replace, and here you can replace the 2 OH minus ions. Very simple. And whatever that equivalent weight of the sodium hydroxide is equal, what is the molecular weight of the sodium hydroxide? That is 40 divided by how many OH minus ions are there? Only 1. So that 40 by 1 is equal 40. 40 by 1 is equal 40. Similarly, the equivalent weight of the calcium hydroxide is equal to, what is that? So what is the calcium hydroxide? That is 74 divided by how many OH minus ion replaceable? It is 2. So that it is 74 by 2, it is 37 around. Okay, if some aluminum hydroxide is there, so here it is replaceable OH minus ions is the 3 OH minus ion. So that you have to take here it as a 3 by 3 by 3. Okay, very simple examples, right? Okay, so this is the way to calculate the equivalent weight for the bases, right? Okay, so you see the example aluminum hydroxide. If 1 OH minus replaces, it is a 78 by 1. If 2 OH minus ions replaces in the same aluminum hydroxide, it is 78 by 2. It depends on reaction. It depends on reaction. If suppose in an exam, in a competitive exam, they asked this they gave this reaction and asked you the equivalent weight of the aluminum hydroxide, then you have to see that how many OH minus ions are replacing. Okay, of course right now you don't require this much. And the next is that the equivalent weight of the salt. Equivalent weight of salts. Okay, so what is the equivalent weight of the salt? Is that very simple. The equivalent weight of the salt is equal to, again, the molecular weight of the salt, molecular weight of that salt divided by the total number of either positive ions or negative charges. Okay, total number of positive charge or the negative charge. Okay, you know that generally in the salt, you take an example of the sodium chloride. You know that generally the sodium chloride is, you can write it as a Na plus Cl minus, right? So that means in this sodium chloride there will be some positive charge and there will be some negative charge. Okay, and how much total? The total only one sodium plus is there. The total positive charge is 1 and the total negative charge is 1. Okay, so that you have to take either this or this. Okay, generally both are same. Generally in a salt both will be same. Okay, so you see here for the sodium chloride, that is 58.5 divided by 1, because you can write the sodium plus Cl minus, sodium plus Cl minus. Okay, so here it is the charge is positive charge, total positive charge is 1 and here is also total negative charge is 1. Okay, next come to the calcium chloride. So calcium chloride, how you can write the calcium chloride? You can write it as a calcium 2 plus 2 Cl minus. Okay, so what is the total positive charge here? It is a 2 and total negative charge 2 into minus 1, so that again it is minus 2. So you have to take either the positive charge or the negative charge. మళ్ళీ రెండు కంబైన్ గా తీసుకోకండి. పాజిటివ్ 2 ఉంది సార్, నెగిటివ్ 2 ఉంది, సో 2 + 2 4 అని తీసుకోవద్దు. అయితే పాజిటివ్ చార్జ్ అయినా తీసుకోవాలి లేదంటే నెగిటివ్ చార్జ్ అయినా తీసుకోవాలి అన్నమాట. ఓకే, యూ షుడ్ నాట్ కన్ఫ్యూజ్ హియర్, రైట్? సో దట్ the molecular weight of the salt enta ikkada 111. Okay, so that is divided by 2. Similarly aluminum trichloride, so what is the molecular weight? 133.5 divided by aluminum 3 plus 3 Cl minus. What is the total positive charge? +3. What is the total negative charge? -3. So you have to take either one, either +3 or -3, but you should not take the charges plus or minus. Okay, you have to take the number, that is 3. Right? Okay, so like this you have to calculate the equivalent weights of the salts, right? And the next is that the equivalent weight of the oxidizing and reducing agents. So these, if you want to understand this, you should have an idea that what is the oxidizing agent and what is the reducing agent. Okay, and these things we will discuss clearly in the later part of this chapter, but right now you keep these things in your mind. One, what is the oxidizing agent? It is nothing but the species which participates in the reduction reaction. Oxidizing ante reduction lo involve ayi untundi annamata. Okay, you have to remember, this is the only thing. What is the oxidizing agent? The species which participates in reduction reaction. Again, what is the reduction? Asal reduction ante enti, oxidation ante enti, ivanni we will discuss later. You just keep this in your mind. Okay, so what is that oxidizing agent? Generally it participates in the reduction reaction called as the oxidizing agent. Similarly, what is the reducing agent? Reducing agent ante that species which involves in the oxidation. Okay, so ikkanemo reduction lo involve avutundi, ikkanemo oxidation lo involve avutundi annamata. Okay, very simple, right? So then just to see one example, that zinc reaction with the copper 2 plus, it gives the zinc +2 plus copper 0. Okay, so paina unna enti ante red color, this is the oxidation number on the zinc is 0, copper paina oxidation number +2, and reaction అయిపోయిన తర్వాత zinc 0 నుంచి it is converting to the zinc 2 plus and copper 2 plus ఏమవుతుంది? copper 0 గా కన్వర్ట్ అవుతుంది అన్నమాట. Okay, this is a one simple example you have to remember. Okay, this is simply nothing but a redox reaction. ఎందుకంటే ఇక్కడ reduction oxidation అవుతుంది. మరి reduction అంటే ఏంటి అంటే వెరీ సింపుల్, ద కాపర్ +2 నుంచి కాపర్ 0 అవుతుంది, అవునా కదా? ఆక్సిడేషన్ నెంబర్ అంటారు దీన్ని +2. సో ఆక్సిడేషన్ నెంబర్ అనేది డిక్రీజ్ అయితే +2 నుంచి 0 డిక్రీజ్ అవుతుంది కదా, రైట్? ఓకే, సో దట్ జస్ట్ ఐ am writing here. So what is this? What is this? If the oxidation number decreases, then you call it as a reduction. Similarly, the oxidation number, if it is increases, then you call it as a oxidation. సింపుల్ గా మీరు ఈ రెండు గుర్తుపెట్టుకోండి. ఓకే, రైట్? సో ఇక్కడ ఫస్ట్ కేసు చూడండి, జింక్ అనేది 0 నుంచి +2కి అంటే, సో 0 to +2 అంటే 0 కంటే +2 పెద్దది కదా, సో దట్ ఇట్ ఈస్ ఇంక్రీజింగ్, సో దట్ యూ కాల్ ఇట్ యాజ్ ఎ ఆక్సిడేషన్. సిమిలర్లీ కాపర్ ఏమవుతుంది? +2 నుంచి 0కి వెళ్ళిపోతుంది, రైట్? so that here the oxidation number is decreasing, so that you call it as a reduction. Okay, right, very simple. Okay, so here it is a reduction. The copper 2 plus is undergoing in the reduction and zinc is undergoing to the oxidation. Okay, మరి ఇందాక చెప్పినట్టు ఆక్సిడైజింగ్ ఏజెంట్ అంటే ఏంటి? ఆక్సిడైజింగ్ ఏజెంట్ అంటే which is involves in the reduction, which involves in the reduction, so that here copper plus 2 is the reducing agent. Okay, copper plus 2 is reducing agent, right? Okay, look at here, the species which is participates in the reduction. Okay, so that you can write here the copper 2 plus, copper 2 plus is nothing but it is involves in the reduction, so that you can call it as a oxidizing agent. Okay, and what is the reducing agent here? Which involves in the oxidation, right? Okay, so that is the zinc is nothing but the reducing agent. Reducing agent. Okay, very simple. Now are you clear about this? Okay, now we can see that oxygen agent's equivalent weight. First we can calculate the equivalent weight of the oxidizing agent. Oxidizing agents. Okay, so generally for the oxidizing agents, the KMnO4 is a very good oxidizing agent, and in the acidic medium generally it will convert from MnO4 minus to the Mn2 plus, Mn2 plus. Okay, so that means the oxidation number of the manganese is the +7. ఎలా వస్తుంది అంటే తర్వాత చెప్తాను ఎలా క్యాలిక్యులేట్ చేయాలనేది. సో దట్ ఈస్ ద మ్యాంగనీస్ అనేది +7 నుంచి వెళ్ళి +2 కి కన్వర్ట్ అవుతుంది. ఓకే, సో దట్ మీన్స్ ద N ఈజ్ ఈక్వల్ 5. హౌ మచ్ ఇట్ ఈస్ చేంజింగ్? +7 to +5, +7 to +5. So oxidation number is decreasing. Oxidation number is decreasing. Okay, right. So what is the equivalent weight of the oxidizing agent? Oxidizing agent. Oxidizing agent అంటే ఎప్పుడు అంటాం మనం? ఆక్సిడైజింగ్ ఏజెంట్ అంటే which involves in the reduction. Which involves in the reduction. Reduction అంటే ఏంటి? దాని యొక్క ఆక్సిడేషన్ నెంబర్ అనేది రెడ్యూస్ అవ్వాలి. ఇక్కడ ఆక్సిడేషన్ నెంబర్ అనేది రెడ్యూస్ అవుతుంది. ఓకే, సో దట్ మీన్స్ ఇట్ ఈస్ ఏ oxidizing agent. So for that you have to calculate the molecular weight of the oxidant divided by the N. What is the N? The N is nothing but the number of electron transferred or involved or changed in the oxidation number. సో ఎక్కడ క్యాలిక్యులేట్ చేస్తామంటే మ్యాంగనీస్ ఇంతకు ముందు +7 ఉంది, అది రియాక్షన్ లోపల +2 కన్వర్ట్. సో ఓవరాల్ హౌ మెనీ ఎలక్ట్రాన్స్ ఆర్ చేంజింగ్ ఆర్ కన్వర్టింగ్? ఇట్ ఈస్ 5 electrons. ఓకే, so that means the molecular weight of the oxidant, if it is a 158 divided by the number is 5, the number is 5, that is equal 158 by 5, it is 31.6. okay, similarly the same KMnO4, if it is in the basic medium, generally it will convert from +7 to +6. okay, so that means how much the change is? Only 1, so that it is 158 by 1, it is a 158. okay, and same KMnO4 in the neutral medium, that the KMnO4 it will convert into the MnO4 minus to the MnO2. So here +7 oxidation state, here is a +4, so that the change is 3, so that same 158 divided by 3, right? Okay, very simple. Next, this example I am not going to be explained, just we can go to the reducing agent. Similarly to the reducing agent. Okay, so what is the reducing agent? You take the H2C2O4, generally it is a very good reducing agent, and here you take it as a C2O4 2 minus. So on the carbon the oxidation number is +3 and it will convert into the carbon dioxide. On the carbon the oxidation number is +4. Don't confuse, మీరు బాధపడాల్సిన అవసరం లేదు. ఈ ఆక్సిడేషన్ నెంబర్స్ ఎలా క్యాలిక్యులేట్ చేస్తామో we can discuss in the later part of this chapter. okay, so here you see that for one carbon the oxidation number change is 1. so for the 2 carbons it is 2. అవునా కదా? సో ఇక్కడ ఆక్సిడేషన్ నెంబర్ ఏమవుతుంది? +3 నుంచి వెళ్ళి +4 కి ఇంక్రీజ్ అవుతుంది. సో ఆక్సిడేషన్ నెంబర్ ఇంక్రీజ్ అయితే దాన్ని ఏమంటారు? ఆక్సిడేషన్ అంటారు. మరి ఏ స్పీసీస్ అయితే ఆక్సిడేషన్లో ఇన్వాల్వ్ అవుతుందో దాన్ని ఏమంటారు? రెడ్యూసింగ్ ఏజెంట్ అంటారు అనమాట. డోంట్ కన్ఫ్యూజ్. ఓకే, so here the total change N is equal to 2. so similarly the equivalent weight of the reducing agent is equal to, again same, the molecular weight of the reductant divided by the N. so N అంటే ఏంటి? again the number of electrons transferred or involved in the oxidation. ఓకే, సో ఎన్ని ఎలక్ట్రాన్స్ ఇన్వాల్వ్ అయినాయి? 2 electrons. ఒక కార్బన్కి ఒక ఎలక్ట్రాన్ అయితే 2 కార్బన్స్కి 2 electrons. ఓకే, సో దట్ మీన్స్ 126 divided by 2. 126 divided by 2. okay, so this is the way So just you practice this. Still if you have any confusion, don't worry, I will explain later. Okay. And anyone, if you are not in a position to understand, just you let me know, I will explain. Okay, don't worry, right? So this is the way to calculation of the equivalent weights. Okay, and in the next lecture, now we are going to see the next topic, that is the percentage composition. And with that percentage composition, we can also calculate the molecular formulas and empirical formulas. Okay, right.